Okay, here we go with section 9.3, rotations, which are turns, basically. Again, these are still examples of rigid motion because the size and the shape are not going to change, but the orientation will change because it's turning. So a little bit of background, which I probably should have done in the earlier sections, is to just make sure that you understand the coordinate grid. So again, it's broken into 4 quadrants, and the quadrants are labeled in a counterclockwise order. So 1, 2, 3, and 4. If you think about it, when we're rotating, each quadrant is kind of worth 90 degrees because again, an entire circle is 360 degrees, and 360 divided by 4 is 90. So when we go over the rotation rules, they are based on rotating counterclockwise. So counterclockwise is in this direction. Clockwise would be in that direction, named for the old-timey clocks that still had hands. So these get a little bit more complicated because you can't just count like we could with translations and reflections, but we're still sticking to the easier rotations. We're not going to worry about constructing or any of that. So all of these do have rules that can be followed. So the first example is rotating 90 degrees. Again, we're rotating counterclockwise. So that's why, again, my original figure is here and my translated figure is here because it sort of moved over 90 degrees in the counterclockwise direction. And the rule for this is that you would take the coordinate points of the original figure, the pre-image, and then what you're going to do is switch them and then make the first one the opposite sign of whatever it currently is. Okay, it doesn't mean that the coordinate always has to be negative. The negative in all of these rules just means do the opposite of what's already there. So I plotted my points. So point M is -5, -5. O is -3, -1. And P is -1, -3. Then I'm just going to apply this rule. Okay, so whatever was y becomes x and the sign changes. So since y was -5, this is now +5. The x stays, but now it's the y. My x and y, okay, so the y coordinate now becomes the x and the sign changes. So -1, 1, and the x just becomes now the y. And P, -1, -3. Again, I'm switching the coordinate numbers and changing the sign. So the opposite of y would be 3, and x stays. It's kind of hard to explain, and that was a little jumbly since I've done a lot of these today and it's kind of late. But again, you should be able to see the pattern, okay? So the biggest thing is just to make sure that you understand that negative in here doesn't mean the sign has to be negative. It's the opposite of what it already is. And then when I plot those, again, here I go. It looks like it could have been a reflection, a flip, but if you look, the corresponding points don't match because this is P and that's O, and then O is up here and that's P. So even though it looks like a flip, it's not. It just coincidentally ended up looking like that. But again, each point kind of swung over 90 degrees. When you rotate 180 degrees, again, that's half a circle. So each point should generally move 2 quadrants over from where it currently is. The rule here is to keep the numbers in the same order, but change the signs on both. That's what that means. So in my original figure, A was 0.42, B was 3, -1, C was 1, 0, and D was 2, 4. So if this is 4, 2, it is now -4, -2. 3, -1 is now -3, 1. Because again, I'm keeping the order, switching the signs. 1, 0 is now negative 1, 0, and 2, 4 is now negative 2, negative 4. And then I just plotted that out. And again, I'm kind of thinking in terms of each point would have swung around 2 coordinates over, 2 quadrants over from where it is right now. When I rotate 270 degrees, again, everything should be moving over 3 quadrants from where it currently is. So I'm still starting by plotting my points of my original figure. So Q was negative 2, 2, which is right here. R was negative 4, 1, negative 1. S was negative 3, negative 4. And T was 0, negative 3. The rule for this is to switch the order of the numbers and then have the opposite sign of what X already is. So if this is negative 2, 2, I'm switching the numbers, which it's hard to tell because they're both 2's. But since this X was negative, when I do the opposite, I get positive. So if this is negative 1, negative 4, I'm switching the numbers and then switching the sign of whatever X was. That's how I get negative 1 and positive 4 instead of negative 4. If S is negative 3, negative 4, I switch to the numbers and change the sign of whatever X was. T was 0, negative 3. I changed the numbers, but since X was 0, it's still just 0, and I plotted that out. And again, if I'm looking at each point, it should have swung around 3 quadrants. So if S is here, 1, 2, 3 quadrants over, now it's there. These rotations are a lot more difficult to really check visually because it's hard to tell what it's supposed to actually look like. So really what you have to be really aware of is just making sure that you're very careful about plotting the points and then careful about following the rules. I guess the only check that you could really do, as far as I know, is to again look at each point and at least make sure it moved over enough quadrants based on the degree measure you were rotating. You wouldn't really ever rotate 360 degrees because you just spun around in a whole circle and ended up exactly where you started. Again, if you're just told to rotate something a certain amount of degrees, you're assuming that that is in the counterclockwise direction. If it specifically says clockwise, though, there's not really a rule for clockwise. But what you have to understand is that if I'm starting here and I'm rotating 90 degrees clockwise, here is where I would end up in this quadrant. That is the same rule as 270 degrees because going 90 degrees clockwise is the same as going 270 degrees counterclockwise. If I had to rotate 270 degrees clockwise, pretty much the same general idea. Okay, so if I started here and I'm rotating 270 degrees clockwise, that's 3 quadrants over in the clockwise direction. That's the same rule as 90 degrees counterclockwise. So again, unless it specifically states clockwise in the direction, you're just assuming that you're rotating counterclockwise. And that's pretty much it on that. So again, I apologize for the tiredness. Maybe I'll wait until tomorrow to do the last section. And again, let me know if these are just confusing or if the quality's bad. I'm sitting here at my kitchen counter doing the best that I can, but I know there's kind of a weird shadow, but hopefully everybody's still able to get the idea. So again, don't hesitate to contact any of us if you need some questions answered, and I will see you again on the next section.